The goal of this lesson is to understand the concept of contour lines. This picture demonstrates what a hill or mountain looks like on a topographic map. A topographic map converts a three-dimensional mountain or hill into a two-dimensional image. Each of these rings are called contour lines. A contour line represents land elevation. The starting elevation for this example is 8,300 meters. The next contour line shows 8,400 meters. This is because the contour interval is 100 meters. The contour interval is the difference in elevation from one contour line to the next. Therefore, the next contour line would represent 8,500 meters, the one after 8,600 meters, and so on. If the contour interval was only 10 meters from the starting point of 8,300 meters, then the next contour line would equal 8,310 meters. The following one would be 8,320 meters. Therefore, it's always important to examine the contour interval to see the scale. Then you'll want to identify the starting point of the land elevation so that you can determine the land elevation of all contour lines. Now for all you visual learners, I'm going to show you how this three-dimensional mountain transforms into a two-dimensional image that is represented on a topographic map. To keep this as simplistic as possible, we will be using the same contour intervals and starting land elevation from the previous example. The contour interval is 100 meters, and the starting land elevation is 8,300 meters. From this example, we will be calling our mountain Mount Everest, which is the highest and tallest mountain in the world, with a land elevation over 8,800 meters high. Now we are going to break apart this model of Mount Everest to give you a visual representation of land elevation. Keep in mind that each Velcroed section represents a contour line. Our goal is to find the highest peak on Mount Everest. I'm going to draw around each contour line on the mountain the width of each separate section demonstrates contour interval. Therefore, the width of this section and all the next sections following is 100 meters. So this is our starting point, and we are going to draw it on the board. Now that we have finished tracing around the first section, which is considered a contour of Mount Everest, we can plot the land elevation starting point, which is 8,300 meters, and we know that the contour interval is 100 meters. So we're going to start taking apart piece by piece Mount Everest, and you should start to see a similar pattern. So here is section 2, and this section represents a contour line. So we're going to draw this contour line right around the section. It's important to keep in mind that each contour line has to have a distinct start and end point. Therefore, there can't be any dotted lines. It's got to be a full line going all the way around. Okay, And we know that the next land elevation is 8,400 meters. And we know that because the width of this section represents 100 meters, because that is the contour interval. We're going to continue breaking apart Mount Everest. So here's another section. We're going to trace this onto the board as well. And now this contour line is going to represent 8,500 meters. The next section is where it comes a little bit tricky. You're going to have two sections. Two sections to add on the board. However, they both represent the same land elevation. They're both going to represent 8,600 meters. And finally, we have two final sections. We're going to just quickly trace them both on the board here. That section is going to represent 8,700 meters. And the highest point on Mount Everest is 8,800 meters. Now, can you see a comparison from the first activity we did with the two-dimensional image and the three-dimensional model? So the three-dimensional model broke down when it was taken apart into contour lines and showing contour intervals, displayed the exact same image as our two-dimensional object. Therefore, we can identify the relationship between a three-dimensional image and a two-dimensional image. And the two-dimensional image is how it is displayed on a topographic map. This is how a topographic map displays contour lines. Contour lines are always brown, and the brown contour lines are representing land elevation. The task is to identify what the contour interval is for Caddy Hill. We know that the starting land elevation is 1,000 meters. We also know that the highest point on Caddy Hill is 1,122 meters. However, 1,122 meters is not directly positioned on the contour line. You can see how it is horizontal. However, from the display of the 1,000 meter, which is the starting land elevation, the value runs right through the contour line. When a value is displayed in a horizontal line, it means that the hill is higher than the last contour line. Therefore, we have to find out what the contour interval is for Caddy Hills. So what we're going to do is we're going to take 1,122 minus 1,000. That leaves us with 122 meters. Now we are going to count the contour lines. We have 1, 2, 3, 4, 5, 6. So we're going to take the 122 and divide it by 6. However, because it is 1,122, we know that the last contour line represents 1,120. So we're going to take 120 and divide it by 6 because there are 6 contour lines. Then this will give us our contour interval, which equals 20. So now we know that each contour interval and each contour line represents 20 meters. Another important aspect of contour lines is the display of how close and far the lines are. If the lines are very close, it symbolizes how steep the hill is. If the lines are further apart and there's more spacing in between, that means the flatter the land elevation. So you're still getting the 20-meter elevation, but it is over more space. So that way there, it is less steep on that side of the mountain, or the hill in this case.